Yeah, hi. So I'm about to do that same problem which last time which we have seen, but in a recursive way. Today I discussed with one of my colleagues actually. So he's told me to follow the following approach. I'll show you. Mm. So this was my approach as well. Like intuitively, I was also looking at this approach only. So in this approach, what we do first, first thing we do is first thing which we do is we try to find uh, basically to find a brute force approach, right? The first thing you will try and see if you are even able to understand the question or not. If you are able to understand, then you will be able to write a brute force solution. Okay, dp how. Now we'll try to do this brute force solution. Other one will be uh, next one will be you'll try to do recursive solution as if it is dp, because I can be wrong, but what I think is um, for now what I believe is dp problem will always have a recursive solution because tabulation stack and all, right? So save solution. Like I think I have read this as well. If you take this example of Fibonacci, like we have multiple. Suppose this is 5, then you calculate for 4 and 3, right? And again you calculate for 3 and 2. So here and here you are calculating for same problems. So overlapping sub problems you will get. So that will give you an idea how to do uh, memorization or memo something, yeah. Memo something. So let me say memorization. Memorization. And fourth one will be the final dp solution, that we can say tabulation. So either this or this, both will be same. And this both will be most probably will be giving TLE. That is why they are DP problems, because too many sub problems to solve, right? Similar kind of problems, and usually this tree. So yeah, let me check out the. Not me. I mean, let's check out the solution. Brute force we have already done. Cadence algorithm we have already done. So cadence algorithm is there. This one is cadence, which I have written. I guess this is my answer, which I have written. Yeah, intermediate. I will be using correct. This is written by me. Now, let's do the recursive solution. So the basis of cadence algorithm. Using that, I'll do the recursive solution and try to build this binary tree. That or without building the binary tree, I'll try to see if I can, using the recursive solution, I can get the DP solution. So for the recursive solution to work, see, we will have max the OG function, right? So it will be int, that will be the actual sum of the maximum subarray, int public int, and after that max array. Here we'll be passing vector int of array, and yeah, here will be create one integer int answer equals 0, and we'll call this say solution. solution function which will be recursive, right? So let me just say dp, maybe not dp, recursive the solution only, solution. I mean we can just return it, right? Return solution. First thing will be send array, second thing will be sending is the current sum. What is the current sum? Okay, and last thing will be index. Let's say 0. Index is also 0 right now. So we'll write this solution sol function. So this will be int as well, int sol vector int arr 0, 0, not like this, sorry, int answer, int I. In place of answer you can say sum, and yeah. So here we can say if arr dot size is equals I, then we'll return 0, and means this is the base condition if we have reached at the end of the array, and we'll do if sum is greater than 0, we can write here, right? Or sum can be 0, that's not a problem, I guess. Sum should not be negative. Sum is greater than negative. We will be doing one function called solution, and as per cadence algorithm I'm writing solution. Okay, we also, like, if suppose if I keep a global variable in terms of our 0, suppose we have this global variable, we can just use one variable here, global variable 0, or better I would say that would be let's not do this yet. Let's try to do it first here. If sum is greater than -1, you'll call sol arr of I, whatever it is, plus में sum. No, first I'll pass the arr itself, then sum will be arr of I plus sum, and the last thing will be the index, that is I plus plus maybe, why maybe it should be I plus plus, right? And in else, let's do the else. Solution will be sending out arr, comma, nothing to sum, that means arr of I, that's it, and like for that index the sum will be at least arr of I, or you can say 0 plus arr of I, that is, both are the same things, and last one will be I plus plus. Now this is Like whatever the cadence algorithm is now, I don't think so. We have that mm, answer yet. So. Mhm. It's complete. And let's start with this call, line 0. Okay, so line 0 will first write solution of comma 0 comma 0 and comma int min, right? int min. So let's see how can we do this. Solution is 0 comma 0 int min. Now we have came with, so first condition fails and it will not return 0. Now sum is greater than -1, not true, so we'll skip it. And we'll go to else and we'll say current transfer will be we will execute line number 8. Line 8 will be executed and line 8 will give ARR comma ARR of I is -2, int min is int min only, but before int min this will be 1 now, and now int min. So in stack we have this. Okay. Now we have called new function. Now this function yeah, now we have this -2 and 1. This will be sum, this will be index. So from -2 and 1 we have called. Now that is again not correct, this is again not correct, so we'll get to 1 and this function will call this one. This will say this will say 1 comma 2. Now from 2 they will -3 and this is greater than that, right? So we have not returned anything yet, so another function stack will be there and it is greater and we have 1 there, so sum will be -2 comma. Right now answer is -2, answer equals 1. Now answer is nothing here. Okay, -2, answer is not updating and this will be 3. Next time 4 will be there and it will directly be replaced by 4. Okay, so it will be directly replaced by 4 in this case. Will be there and answer comma sum. Okay, we have not performed sum yet, that's the point. Let's suppose we are behind the sum, so like below the sum, -2. Now no 1 only, and now we are at this. Now if we are getting a thing like minus or something, so 4 is there and after getting 4 we know, yeah, the sum is greater than -1, so we'll do this and we have 4 already. Yeah, 4 already. Answer equals 4 here and 4 already, 4 comma 4. Now next step, and 4 comma 4 is not there, so 4 comma, so yeah, minus 1 we have. Fine, that is cool. 4 minus 1 will be what? 4 minus 1 will be 3 comma 5. Answer equals 4. Next will be and you can see like we have not returned anything. I mean, we are still on in this function as we are not using the keyword return here. Okay, so let's continue. Now we are at 3 comma 5. Answer equals 4. Now not suppose, now we are at 3 comma 5. Now we'll be at fifth index, and 0 1 2 3 4 5. Fifth index is 2, so this will be 5 comma 6, and answer will be 5. Next one will be 6 comma 7, and answer will be 6. Then on forward we will be getting 7, right? Then we will be subtracting minus 5, so this will become 1 comma 7, and this will be, answer will be 6 only, and we will add 4 more, so this will become 5 comma 8, sorry, 1 comma 8, then this will become 5 comma 9. So answer will be still 6, and we will return answer. So we have returned answer. Now since we have returned value answer, this will get answer return as 6, and this function will also return only because other conditions not going to meet. Whenever these were called, conditions are not going to meet, so this single return statement will propagate back, 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 and back. So these answers do not matter because only one answer, return answer is being executed, and our final answer will be 6. Now my one doubt here is like I have done this answer before, like after the call I have actually reversed it in like this one, this line is below and this line is up there. Okay, so now what can we do here? Yeah, try to execute this answer line before. Let's do that. Why this will not work? Yeah, now I will be making the stack again. Stack is there. Now we'll be having answer, I mean the call will be with -2 comma 1. If you clearly see it at line number 4, not at line number 4, at line number 8 this will execute, and answer will be -2 only. Now next we will execute, and sum we have updated to sum we have updated to suppose, not suppose, because we have updated the sum. So sum we have updated with next call obviously we have updated, and sum will be 1 comma 2, right? So 1 comma 2 when it's called, line number 4 will be called, and exactly there we will be updating answer as 1. I guess this will go similar way. I believe I need to change there. numbers. So suppose this one is here and this one is then there, then how this will form? This one is here and this one is then there. Again we have minus 2 comma 1, and next iteration this one will be called no, not this one, this was already called. Okay, now this call has kept, this one is in halt, so we have one line of code which is yet to be executed, and that code is max of answer comma sum is minus 2 and answer here is int min. Now yet we have called another function now, and we are going to else part this time because we have negative value, and else part will make it 1 comma 1 comma 2. Now same stack will be again there, max of answer comma sum. Now sum we have as 1, okay, and answer we still have int min. Is it? Yeah, sum is still int min. Now let's do the next one. As we have 1, we will again execute the above. That will be minus 3 plus 1 will be minus 2 comma minus 2 comma 3, and similarly max answer comma sum, and so on. Now to the next step, let me reduce its size. Okay, we have reduced it. Now here at minus 2 and 3, so 0 1 2 3 4 is there, minus value we have, so 4 will be directly here. 4 4 comma 5, same max comma answer comma sum. Now 4 comma 5 will become 3 comma 6, again max comma answer comma sum, and then again 3 comma 6 will become 3 comma 6 will become 5 comma 7, 5 comma 7, again max of answer comma sum. Now 5 comma 7 will become 6 comma 8, max comma sum comma answer and max. Now 6 comma 8 will become 5 comma, I believe, right? No, will become minus 5, so 1 comma 8 comma 9 actually, and 1 comma 9, and at last this will become 5 comma 10.
So this will fail and we will get a return value of 0. This will return 0 and there will be function this max of answer comma sum. Here sum is 5, so we are going to get answer barabar 5 here. Okay, at this place again max comma 5 answer barabar 5 again. At this place you will get answer equals 6 because answer comma sum and answer is 5. Again we'll go there and max of 6 comma 5 will be 6. Answer again answer barabar 6 again answer not 6 yeah answer barabar 6. I guess this is doing it in reverse actually, and reverse subarrhythm is also fine only. So again 6 and again answer equals 6. So we have propagated back. Answer we have determined is going to be 6 because this time it has ran, and finally we are returning. So in this specific problem, the point to be noted is that answer is going to be like this. Answer equals max of answer comma sum. This is the one, right? So this thing we can place anywhere before or after call, but I do believe like there are some questions where this placement of this are important, so don't think like this is the only way. Okay, let's try it out, code it out and see if this does not give the TLE. This is not a proper
recursive solution for finding out the DP solution. This is essentially finding out an DP solution, which has I'm getting feeling of here. Let's see. Okay, now let me do. Yeah, I was watching this. I like that car actually. Lol. Lead code. Cool. Here, maximum subarrhythm already done with cadence algorithm. That's fine. Now, the last thing which is remaining is to do analyze diameter. Oh my god, these things are in pending. My solution on a tree. Tree stack iPad also max depth of a binary tree and try to implement them in iterative way. Yeah, correct. And contains duplicate. Needs to check this one. I believe there was none solution of this one, but this one I have to do. And let's add other points. Tomorrow during the job time or something I'll continue. You can I'll try to do it in afternoon or afternoon. So these points will be I need to, like, I don't want too much backlog, so like my mind is not at that question or something like that. Okay, so that will be confusing, and yeah, I'm also speaking gibberish, so sorry for that. So maximum subarray proper DP approach out how and DC approach how. BROCH approach how. Yeah, this is good enough. I can start the coding. So let's do int solution in vector int and nums. That one will be int I, that will be index, other one will be int sum, and last one will be int answer. And yeah, if I equals nums dot size, then we can say turn 0, and we can continue. I can say if sum is greater than -1, then we'll call solution nums comma I plus plus comma sum plus min nums of I, and I hope this will work. Yeah, nums of I and answer, and you can do answer equals max of answer comma sum, and similarly I can do in else, and answer equals max of answer comma sum. Solution is going to be nums of I plus plus, that is fine. Then we'll just do nums of I and answer. You can directly return answer. Here we can do return nums comma 0 comma 0 comma 0 or int min. Let's go min. So last one is also this here. Let's see. Dry run was fine. Okay, what's the problem? Let me analyze once. If sum is greater than -1, we are checking the maximum of answer, and we are adding up the sum and passing it as a sum, and the answer as well. Let's do this. Before doing this I plus plus, let's move this from here. I plus plus. Similarly, yeah, and sum, and this should try it. Also again. some problem. Yeah, it is back returning the answer. Maybe return, and let's do it return. This is a little questionable for me. So before returning, I should calculate, right? Yeah, and yeah, if this works, I'll get. I have some answers. If it doesn't, I'll have to do something else. Yeah, I'll have to do something else. Hmm. Okay, got the point. Let me just undo everything for few seconds. Let me write down everything back, and the initial state it was. Let me remove this return statements. This is fine. 1 plus 1, maybe let's do plus plus for once. So solution, okay. Yeah, let me run this. Okay, overflow is there. Fine. To make a return, yeah, I'll do not like this. Yeah, nice. And then I'll return, and then I'll return. Let's see. TLE. This is because of I plus plus, I believe. I plus 1 and plus 1. Now let's see. So at least we are not getting any garbage. We are getting 0. And this return 0 is causing that, most probably. What if it return answer? 6 we got. That's cool. Okay. Need to understand why my dry run was working. Let me just make some solutions here. Attempts to divide it. White will be this, and we'll be doing this ampersand, so it is by reference. And we'll be doing this, and we will not returning anything. We'll be having int answer equals int underscore min. I'm calling this function. Return answer.
don't actually stay tuned and don't actually lose focus.